Welcome to another episode of Physics with Joe. Today is all about adding vectors by using their components. In previous videos, I talked about the difference between vectors and scalars, how to add vectors graphically using the tail to tip method, how to calculate the x and y components of vectors using my patent pending Southern California approach, and last but not least, how to get the magnitude and direction of a vector if I have its x and y components. Well, today we're going to be combining all of those and looking at how do I add two or more vectors together by using their components. So let's jump right into it. Let's take a look at adding two vectors together graphically using the tail to tip method, and that'll help illustrate for us how you add vectors together by using components. I've got two vectors, A and B. Remember, with the tail to tip method, you start with one vector. Here I'll start with vector A. You draw it to the correct length and in the correct direction. And then the next vector, vector B, we draw starting at the tip of vector A. And then the sum always starts at the tail of the first vector and ends at the tip of the second vector if you're adding two vectors. In this case, you can see the sum starts at the tail of vector A and ends at the tip of vector B. This is how you would add vectors together graphically. It's a great way of double checking your result. However, I want to use this also to illustrate how we add vectors together using components. Just as a reminder, let me turn off this sum. A vector component is really just how much of a vector points along a given direction. The x component of a vector is how much of that vector points along the x-axis. Y component of a vector is how much of that vector points along the y-axis. For this particular case, you can see my x component of A points to the right. My y component of A points straight up. For B, again, my x component also points to the right. My y component points straight up. And let me bring this sum back. Let me offset this a little bit and show you that if I take the x component of A and I add to it the x component of B, what I get is the x component of the sum. When you add vectors together using components, all you're really doing is just adding all the x components together to get the x component of the sum. Same thing is true for the y component. Again, let me offset this a little bit. If you look at the y component of A, and I add to it the y component of B, what I get is the y component of the sum. So if I want the y component of the sum of two or more vectors, I just add all the y components of the vectors together. Let's now take a look at the simple three-step procedure for adding two vectors together using components. Now this will apply for adding 3, 4, 5, 6 vectors together, but for this particular example, I'm just assuming I'm adding two vectors A and B, and I'm calling the sum of my two vectors R for resultant. Step 1 is you break each vector up into x and y components. Now, one or more of those vectors may already be in x and y components, but if you're given the vector in terms of a magnitude and a direction, first thing you want to do is calculate the x and y components of each vector. Simplest way of doing this is my patent pending Southern California approach. SoCal says the following. X or y component of any vector is always plus or minus the magnitude of the vector times either sine or cosine. The plus or minus is going to depend upon whether the component should be positive or negative, which will depend upon whether it's pointing in the positive or negative direction. So if you have the x component that points to the left, that x component should be negative, so you have to manually put in a minus sign. If the y component points straight down, that y component should be negative, so you have to manually put in a minus sign. Magnitude of the vector is just the magnitude of the vector. Now, whether you use sine or cosine will depend upon whether that whether that component is the opposite side or the adjacent side to the angle that you're using. If it's the opposite side, we use sine. If it's the adjacent side, we use cosine. Sort of where the SoCal comes from. I just remember sine, opposite side. Cosine, adjacent side. That's really all you need to know to calculate the components. Plus or minus, magnitude of the vector times either sine or cosine. Sine if it's the opposite side, cosine if it's the adjacent side. Step 2. Now that you have x and y components of each vector, all you're doing is adding all the x components together and adding all the y components together. The x component of the sum of two or more vectors is just the sum of all the x components. The y component of the sum of two or more vectors is just the sum of all the y components. So you add all your x components together, you get your resultant x component. You add all your y components together, you get your resultant y component. Now you've got the x and y components of the resultant. All you do is calculate the magnitude and direction if needed. Now, if you only need the x and y components, then you're done. But if you do need the magnitude and direction, very simple. Calculate the magnitude, Pythagorean theorem. It's the square root of the x component squared plus the y component squared. To calculate the angle, we're going to use the inverse tangent of the y component divided by the x component with one caveat. Your calculator will only ever give you an answer when using inverse tangent in the first or fourth quadrant. If you know the answer should be in the second or third, you have to add 180 degrees to the answer your calculator gives you. How are you going to know if the answer should be in the second or third quadrant? Quite simply, if the x component is negative, then that angle should be in the second or third quadrant. So anytime you're doing inverse tangent and the x component is negative, your calculator will give you the incorrect angle and you need to add 180 degrees to the answer. And that's really all there is. Let's do a numerical example and just put this into practice. For this particular example, we're going to add together two force vectors A and B to try and find the total force, or the sum of these two vectors. Vector A has a magnitude of 12.2 newtons and is located 35 degrees below the positive x-axis. Vector B has a magnitude of 23.9 newtons and is located 57 degrees to the left of the negative y-axis. Remember, our very first step is to break each vector up into x and y components. Let's start with vector A. So I know the x component of A points to the right, so it's positive, and it is the adjacent side to this 35-degree angle, so I'm going to use cosine. The y component of vector A points straight down, so it should be negative, and it is the opposite side, so I know I'm going to use sine. So my x component of A plus 12.2 newtons times the cosine of 35 degrees. The y component of A is minus 12.2 newtons times the sine of 35 degrees. And what we get for the x component is plus 10 newtons. What we get for the y component is negative 7 newtons. So the x component of A, 10 newtons, the y component, negative 7 newtons. For vector B, the x component points to the left, so is negative, and it is the opposite side to the 57-degree angle, so we're going to use sine. The y component points straight down, so it's negative, and in this case, it's the adjacent side to the 57-degree angle, so we're going to use cosine. The equation for the x component of B is then negative 23.9 newtons times the sine of 57 degrees. The equation for the y component is negative 23.9 newtons times the cosine of 57 degrees. What we get for the x and y components of vector B are, the x component is negative 20 newtons, the y component is negative 13 newtons. So that was step 1. Calculate the x and y components of each vector. Step 2, very simple. All we do is add all of the x components together to get the x component of our sum, and we add all of the y components together to get the y component of our sum. In this particular case, we get ax plus bx equals 10 newtons plus a negative 20 newtons. So my x component of the sum is negative 10 newtons. Ay is negative 7 newtons. By is negative 13 newtons. So my resultant is negative 7 newtons plus a negative 13 newtons, negative 20 newtons. Again, we just add all the x components together, add all the y components together. So my sum of these two force vectors has an x component of negative 10 newtons a y component of negative 20 newtons. That is in the third quadrant since we have a negative x and a negative y component. So I know that when I use inverse tangent on my calculator, it's going to give me an incorrect answer, and I'm going to need to add 180 degrees. Final step, let's just calculate the magnitude and direction of the sum of these two vectors. To get the magnitude, I'm just going to take the square root of the x component squared plus the y component squared. So the square root of negative 10 newtons squared plus negative 20 newtons squared, and what I get is 22.4 newtons. And to get the angle, I'm taking the inverse tangent of the y component divided by the x component. In this case, it's the inverse tangent of negative 20 newtons divided by negative 10 newtons. The calculator will give me an answer of 63.4 degrees. But that is in the first quadrant. Our angle should be in the third quadrant, so we add 180 degrees to the answer our calculator gives us. The angle is actually then 243 degrees. So the sum of these two force vectors has a magnitude of 22.4 newtons and an angle of 243 degrees. And that's really it. If there were 3 or 4 or 5 vectors, nothing about this changes. Calculate the x and y components of each vector, add all the x components together, add all the y components together, and then just calculate the magnitude and direction of your sum. That really is all there is.
That was easy.
Thank you so much. I really appreciate you joining me today for Physics with Joe. I hope to see you next time where we'll be talking about something fascinating. Until then, whoosh, I need a tagline.